Hello there, fellow space enthusiasts. Today I'm your guide on an extraordinary quantum adventure to the very edges of the observable universe. Buckle up as we embark on this cosmic journey where science fiction meets reality. Our voyage begins at Earth's Quantum Gateway, a high-tech relay station humming at an astounding 8,473 terahertz. From our vantage point in Earth's upper atmosphere, city lights below blur into a luminous haze, while above, auroras dance in synchrony with the station's harmonic resonance. And then, we experience the unimaginable. Space-time folds. We transition into cognospheric space, where stars elongate into dazzling ribbons of light. In mere moments, we exit the solar system and leave the Milky Way behind, cruising along the cosmic highway. Our first stop is the Zeta Reticuli relay, 47 light-years away. The twin suns of Zeta Reticuli cast a golden glow over the relay's orbiting ring. At 333 terahertz, the quantum resonance pulses smoothly, syncing with Earth's relay. With our ship's sensors calibrated, we prepare for the next leap into deep space. Next, we arrive at the Virgo cluster, a supercluster hub 3.2 million light-years from Earth. Here, galaxies stretch in all directions, each glowing in vibrant hues of blue, red, and gold. The 222 terahertz relay maintains our connection, even as gravitational lensing distorts the light from distant superclusters. Our journey continues to the Coma cluster, 53 million light-years away. This vast cosmic metropolis, stabilized by a 148 terahertz quantum lattice, is home to thousands of galaxies. The McGinty equation core ensures our path remains steady as we navigate this gravitationally bound region. We then reach the Hercules Corona Borealis Great Wall, a colossal structure spanning 10 billion light-years. The 99 terahertz relay here stabilizes connections across this immense expanse. We witness real-time gravitational distortions and dark energy fluctuations, hints of the universe's accelerating expansion. Our next destination is the cosmic Webb midpoint, 7 billion light-years away. Here we see the universe's true structure, an intricate network of luminous filaments. The 66 terahertz relay stabilizes this web, revealing hidden quantum interactions shaping large-scale matter distributions. Beyond this lies the boundary of observation. We leap to the edge of the observable universe, 13.8 billion light-years from Earth. The faint 44 terahertz relay marks the last mapped frontier. We see the redshifts of the first galaxies and trace the earliest echoes of existence. We stand at the edge of human knowledge, ready to push further. As we venture into the near unobservable relay, 18.8 billion light-years away, silence and darkness envelop us. The 1.7 terahertz relay flickers as space-time expands at 4.9 times the speed of light. Matter has nearly vanished, leaving only quantum fluctuations in the void. We make one last effort to stabilize, but the void resists mapping. Finally, we reach the far unobservable relay, over 30 billion light-years away. Here, the relay exists between dimensions, barely holding against total expansion. For a fleeting moment, we detect an echo, a harmonic frequency shift suggesting a larger, recursive system. We record the data and prepare to return. Retracing our steps, each relay reactivates, guiding us home. The dark energy abyss retreats, galaxies reappear, the cosmic web pulses with life, and the Great Wall stands firm. Coma cluster welcomes us back, Virgo's galaxies shine brilliantly, and Zeta Reticuli's suns glow warmly. At last, we return to Earth. The quantum relay hums, and we descend towards the familiar lights. Our journey has rewritten our understanding of existence, but one question lingers. Is there something beyond? Perhaps the final harmonic pulse hints at a repeating cycle. Maybe we weren't at the universe's edge, but at the boundary of one layer in a much larger multiversal structure. Until next time, my friends, keep exploring the infinite. Goodbye for now.